Greetings everyone, I am Hasnain Ali and in this video I am going to elaborate how to make Waveguide rectangular 90 in HFSS, then we will make its design on SolidWorks. So let's begin with a simple introduction that WR-90 waveguide is a type of a rectangular waveguide that is commonly used in microwave communication systems for transmitting and receiving signals in the frequency range of 8.2 GHz to 12.4 GHz. This is the standard design of WR-90 waveguide, and here the frequency band as described in the definition is 8.4 to 12.4 GHz. Then the standard dimensions are 22.86 and 10.16, both are in millimeters. So the cutoff frequency can be calculated from this formula. So for suppose if we want to calculate TE10 mode, dominant mode, the cutoff frequency will be 6.56 GHz. So when we put these values here, we will get this frequency. So let's start making its design in HFSS. So I will open HFSS. Insert HFSS design project. So at first we will create a vacuum box. Now pick up a cubic box here and draw it. And give it a name vacuum box. Give it a color. And the material is already set, which is vacuum. Now we will go to create box and assign the dimensions. So let's give it a variable A, which is 22.86. Y size should be B, which is 10.16. And Z size should be L, which should be approximately double of A, which is 45.5. And the position should be minus A by 2 minus B by 2 and 0 mm. Yes. And click OK. So this vacuum box is ready. Now we will make another box over it, which will be called copper metallic box. So we will simply copy and paste it and we will update it. Let's give it name copper metallic box, and the material should be copper. And give it the color, this one. Now update its dimensions. We will give it a thickness which must be 0.2 mm. Also in Y size. And we will also update its position minus TH. So here the metallic box is ready over here. Now we will make a radiation box. So pick up another cubic box. Give it a name radiation. Material should be air. Now let's update its dimensions. It should be A plus 10 mm, B plus 10 mm, should be minus AY2 minus 5 mm, should be minus B/2 5 mm. So the radiation box is ready over here. Let's increase its transparency. Yes, updates. It's Z, which should be L. So this one, the design is ready. Now we will make its solution type as Eigenmode. And why we are doing it Eigenmode? Because we have to check it in modes like TE10. The highest mode should be of the equivalent to critical frequency, which was calculated for TE10 mode. So here we will right click on analysis, add solution setup. Minimum frequency should be 5, which must be less than the critical frequency. Number of nodes, let's give it 5. Minimum pass is 10 and 0.02. We will check it, then we will simulate it. Let's save it in desktop. Simulation will take time. So the simulation is done. Now we will see Eigenmode data analysis setup 1 and right click the setup 1 and we will go to Eigenmode data, and we can see that the highest mode, which is mode 1, has a critical frequency of approximately 6.56 and 6.58, which is almost same after tuning the dimension properly. So we have received the critical frequency at the highest mode at mode 1. Furthermore, we can also visualize the vector E or vector H pattern here. So we will right click it on copper metallic box and we will go to plot fields, and here we will select vector E and then click on done. We will go to field overlays, field E, and we will right click field E1 and we will animate it. Select OK. So this is the visualization of vector E radiations. So in this manner, in Eigenmode, we created WR-90 in HFSS. Now we will move towards SolidWorks for making its design. So now WR-90 waveguide uses SMA port. So this is the rough sketch of available SMA port. We will follow this and create design in SolidWorks. And this is the real picture of SMA port which can be used to connect WR-90 waveguide. So we have opened SolidWorks. We will go to part. We will select front plane and sketch. Let's select center rectangle. We select it, and the unit must be mmgs. We will again go to sketch 1 and edit sketch. Now here in the rough sketch we can see that the dimensions of available SMA port, which is 41 mm by 41 mm. So we will assign smart dimension 41. This one also 41. Click it and now we will extrude it. The sketch is fully defined. Now the thickness of the available SMA port is approximately 5 mm. So we will select 5 and we will check it. Now we have to chamfer these edges. So now we will select here the chamfer option. This double distance option and chamfer parameters are asymmetric. So we will see that here the chamfer distance is 4 mm. So we will assign 2 mm here and also 2 mm here, which will make 4 mm distance. So we will select this edge. Okay. Now we will take this and we will rotate it. Zoom it. Now click this chamfer 1 and edit feature, and now select this edge. Now check it. Again rotate it for the remaining two edges. Again click on chamfer 1 in edit feature. Now select the remaining edges, this one and this one. So we can see that all four edges have been chamfered. Now we have to make holes for screws. So for this we will select this face and sketch, and we will make 4 circles here. At first let's make 2 circles, one here and in this alignment one here. Right click and select both one, and we can see that the diameter of these for both circles or 4 circles is 4 mm, and the distance from here, this horizontal distance is also 3 mm, and this chamfered angle and the circle, the distance is also 3 mm. So we will assign these distances. So this is 4 mm, also this one is 4 mm. Now here this and this distance is of 3 mm, and from center to this chamfered edge, this is also 3 mm. Similarly, we will do this thing also here. It's 3 mm, and also from center to this chamfer edge, it is also 3 mm. We can see that sketch is fully defined. Now the same circles we have to draw here. So simply I can use a center line and draw exactly here. Now I can use the command mirror entities, which is here. Now let's select entities to mirror. I want to mirror these both circles, so I will select them. I want to mirror about this center line. We'll click it. The sketch is fully defined. Now I have to make it extrude cut. So I will select here from features, extruded cut, and I will make it through all because I have to make holes here. So we can see that the holes have been created here. So now the design of port is almost ready. Now we have to make waveguide. Means we have to make a rectangle and extrude it here. So the dimensions are given here. So we have to make 2 rectangles. First of all, upper one and this one. So we will make this upper rectangle here 23.26 mm and 10.56 mm, which is basically are the dimensions along with the thickness of that copper metallic material. So we will first of all draw this and we will extrude it. So let's select this face, click sketch. Now we will again select the center rectangle. Now we will assign smart dimensions. This one is 33.26 and this one is 10.56. We will OK it, and now we will extrude it. This must be blind. And what should be the dimension of this extruded part? It should be as same as the length of the waveguide which we assigned in HFSS. What was that? It was 45.5. We will check it now. This extruded boss space is ready. Now we have to make this similar port also here, because input and output ports both are important for a waveguide, as we have also seen in the word file that the standard dimension and standard structure of waveguide is that there should be input port and output port. So we have to make a similar port in the opposite side. So let's select, let's rotate it and select this face, and I will, from the reference geometry, I will select a plane. I will flip offset, and I want this plane in the middle of this, so it must be 22.75. It is the half of 45.5. Okay, I will click it. So here is the plane in the mid of this waveguide. So I will use it as a mirror, and I will mirror these all this whole design towards this side. So I will use this mirror command, and now I will select mirror, which will be my plane 1. From here I can select, and I will select features to mirror. What I want to mirror: boss extrude 1, also chamfer, cut extrude. These things I want to mirror, not boss extrude 2, because it is this one. So I will click it, and I will hide the plane now here. Plane, this one. So on the both sides, the ports can be seen. Now the remaining thing is making a rectangular hole in it for for vacuum, which we also created in HFSS. So here I have defined the dimensions, which are 22.86 and 10.16. So again, we will select this face and sketch. We will select the center rectangle, and we will give it small dimensions, 22.86 and 10.16. Click it, and we will extrude it cut. We will make it through all. We will check this. So here our WR-90 waveguide is ready according to the given dimensions of this SMA port and this tunnel. So we can give it any color from this task pane. Go to appearances, metal, can give it the color of copper. So this is how we can make a sketch of a WR-90 in SolidWorks. So in this video we saw how to make WR-90 waveguide in HFSS, then its design along with ports in SolidWorks. So thanks for watching.